The American chestnut was very common in the Appalachian mountain range, running all the way from Maine down to southern Georgia. This tree is quite common, 1 in 4. Some people say that a squirrel could run on top of the branches, just jumping from chestnut tree to chestnut tree, all the way from the northern Appalachians down to the south.
This is Bob Duchesne's Wild Maine. Once upon a time, the American chestnut was the most abundant tree from here to Georgia. Maybe a quarter of all trees were chestnuts along the Appalachians. Now, they're all dead. Well, most of them. A few survived in the wild, and now some people are trying to bring them back. The where, why, and how that might happen is coming up in today's show. It'll take us to Greenville on the west side of Moosehead Lake, an unlikely place to look because it's possible the chestnuts never grew that far north. And it's a point of land that is more commonly known for lakeside cottages. And we're not even sure of how to keep squirrels from eating the seeds and deer from browsing the leaves. We'll try to give Mother Nature a hand here, but she may be fighting on the other side of this, fighting us the whole way. Bob Duchesne's Wild Maine is brought to you by Hammond Lumber, Doors Equipment, Bar Harbor Whale Watch, Napa Auto Parts, and EBS.
Welcome, everybody. This is the first workshop that the Central Maine SWOM chapter has put on in some years. We're very glad that you're all here to help make this a successful workshop.
That's Gordon Moore. For many years, he was the district forester in the Moosehead area for the Maine Forest Service. He's now retired, and like most retirees, he's busier now than ever. He's the chapter representative locally for the Small Woodland Owners Association of Maine. And this event today is a SWOM workshop. He's the one who roped Peter Kleem into this.
Which means I had no choice in the matter.
Peter Kleem's German accent is a clue that he isn't originally from here. That's why we are here, to get some clues on how to manage these trees not for pulp, but for high-value forest products over a long term. It's a different kind of forest management.
I have about 145 acres of land here, which is really 7 small pieces that have been assembled over time. I started in the early 60s to come up here, was of course a skier, had been at Sugarloaf skiing and saw what happened in Carabasset Valley with A-frames going up all over in an unorganized way. And after we had our place, a cottage, a nice camp down the road a bit here on Harford's Point, kept driving in here and said, oh my God, the cabins were going up on the highway, this is next. And, you know, it was kind of a selfish initial initiative, and I had help from family as we accumulated 7 small pieces of land. Over time, that grew very quickly into a dedication to help create the forest of 100 years, or for 100 years, one that would also be used by the public. It would be a place where you could walk. You can probably tell from my accent, I was born in Germany. As a youngster, grew up there and walked the Black Forest.
There are about 50 people here, mostly foresters and SWOM members. Gary Morris is among them. He's a leading forester for the state. Dave Roque is here. He's the state soil scientist. And Brian Roth is here. He's got a doctorate in forestry and is acting director of the Center for Research on Sustainable Forests at the University of Maine, though he's really here for the American Chestnut Foundation.
Correct, yeah, I'm here as a volunteer with the American Chestnut Foundation.
He'll be the chestnut guy on today's show, and restoration of the American chestnut is what this show is really all about. And we'll get into why this is actually a rather unusual spot to even consider experimenting with chestnuts. The story actually starts with sugar maples and deer.
And what I learned and what you see is that every segment of this forest is different. My attention then was towards preserving and growing really sugar maple. And to help do that in an area where we have deer all around us, this being a game preserve is a real challenge. We have learned together an awful lot about protection and the value and the problems that come with protective tubes. And as we go along, I will talk a bit about that.
That's the first challenge. When you're encouraging seedlings and saplings for high commercial value, how do you keep the deer from eating them? One way is to put protective tubes around them. But how big? How tall? What can go right? What can go wrong? That's one thing all of the foresters gathered here today are interested in finding out. And Peter Kleem is interested in finding out because he also wants to keep those chestnut seedlings from becoming deer food.
I have planted throughout the forest about 20 chestnuts, most of them the original American chestnuts that are not the hybrids, so they're not expected to be resistant to the blight. This is one of those.
So there's an American chestnut right there. It's in the woods just off the trail, and it's in a place that was historically too cold for them.
They've been as far as Atkinson, Dover Foxcroft. That is at least a zone warmer, if not more. Our plantation in part, and I don't want to take Brian's fire here, but is to test also frost resistant of those blight resistant seedlings that are now available before rollout. And that ridge up there is in the order of, I think, 1,300 feet. The lake is at 1,100 feet. And this is a test. If they make it here, they're going to make it.
So this whole thing is a test. This tree in front of us is probably going to die. The same blight that killed all the others will probably kill this one. It may, in fact, be too cold. It may get eaten. It may suffer from the effects of its protection. But it's getting a chance. It's about 6 feet tall, and it's defended by a tube to keep critters from gnawing on it. It's also getting some sunlight. The immediate forest around it has been cut back to allow this tree to flourish. This is something I've been working on in this forest for a dozen years. Gary Morris has done much of that forestry, and it's a change from the kind of forestry many people are familiar with.
As an old forester, I was taught general thinning. And that meant you went through the area and you thinned the whole stand. Pre-commercially or commercially, didn't matter. You did the thinning through the whole stand. And you left the trees that you wanted to grow and got rid of everything else. Well, so Gordon starts talking to me about crop tree release. And basically all crop tree release is you pick the best trees on the lot, whether you've got 5 of them or 500 of them, and you only thin around those. And you forget about everything else and just let it grow. And you'd be surprised what can grow while you're not looking. So that's what we did out here. And again, Gordon's mantra was, touch my crown, you go down. I have never touched Gordon's crown.
You better not either.
No. But that's what we did on those birches and other crop trees. And what we were trying to find is the absolute best of what we had there to work with in terms of straightness. Did it fork shortly, a little ways up? Was it a tight crotch that the ice and snow was going to break and tear apart? Or were they good, strong crotches in the tree? We could keep those. We just thinned around them. And today, it's time to thin them again, 10 years later.
But here's the problem. You can selectively choose tree by tree which one you want to encourage, something you wouldn't do over an entire forest. But a small woodlot managed for high-value trees, you could. But now the trees available for deer food are these. So Peter Kleem gets us back to those tubes we were talking about.
As we first thinned and cleared, we had open areas, and we saw small areas where sugar maple were coming up. And I said, I would like to now really protect sugar maple from deer and browse. And we decided to use tubes. They came in different diameters. This was one of the smaller ones. This was wonderful. We had seen the damage that mice can do and rodents can do. So of course we were going to protect them from mice. And what you do is you push it down, put your stake in, and what we saw was that those trees in that first year came in springtime. The leaves were out at least a week before they were up every place else. It was nice and cozy, warm. In the fall, we saw leaves, green leaves, at least a week and a half longer than we did in other places. because things were nice and warm, they were growing well, and in most cases, about a year later, unless they were tall, they were dead.
First problem, there's not much ventilation down in the tube. That can breed fungus. Also, when a tree grows up tall enough to extend out of the tube, that's the part that's going to get whipped back and forth in the wind, and that can damage the tree. And then back to ventilation. Once leaves begin growing in the top areas of that tube, that can cut off ventilation to the lower reaches of the tube. Everything goes well until it doesn't. So in this very spot on the west side of Moosehead Lake, we're learning about what works and what doesn't.
I think the learning in this is if you use tubes to protect them, make sure you have ventilation just as low as you can. Don't have them longer than you need, and be prepared to change them once after a year or 2 or 3 when the time comes. And you'll see up on top, based on Brian's expertise and others, the tubes that are being used are short.
And the reason we're experimenting with American chestnuts in this place that may be too far north, is that the kind of tree-specific forestry being practiced here is unusual. Before the first chestnut was ever planted here, mistakes were being made so that they wouldn't be made later. Forester Gordon Moore.
As you're listening today and walking through here, you're going to see a lot of techniques. Basically, these are, the term now is continuous cover. In the past, we called these techniques like single tree selection, things like this. And it's a valid technique to use. However, remember, this takes a lot of input. And it takes someone like Peter, who's very dedicated to make this work out. And he not only is treating the overstory in these stands, but he's treating the understory within these closed canopy stands. This is something that's not normally done in forestry in the United States. We almost always just forget about that understory underneath a closed canopy.
So what took this show to Greenville was a chance to find out about restoring chestnuts. Who knew we would also learn about some rather unusual forestry? Looks like Bob Duchesne's Wild Maine has stumbled onto something here because the economics of forestry have been changing rapidly. We'll follow the money. Coming up on Sports Radio 92.9, The Ticket. Welcome back to Bob Duchesne's Wild Maine on Sports Radio 92.9, The Ticket. We're in Greenville today. We're on the way to look at an experimental plot to bring back the American chestnut. It used to be the most abundant tree in the Appalachian forest. How it died out and what might bring it back is all coming up. This event today is a demonstration workshop for foresters and members of the Small Woodland Owners Association of Maine. We're on the land of Peter Kleem, who has been managing 140 acres in a rather unusual way, trying to grow high-value trees like sugar maple, white pine, some spruce and hemlock, and now chestnuts. His team does this by painstakingly going throughout the forest, selecting trees to protect and nurture, and opening up just enough sunlight to encourage them. This just might be where the money is. Once again, this is Forester Gordon Moore.
So while you're looking at this, keep in mind that this requires somebody who is very dedicated and has the resources to make this work out. If your plan is to come in and harvest and walk away for 5 years and do nothing, it's going to fail if you try to do these techniques. You have to be here doing this. For small landowners, you are looking to grow high-value, large stems. Because any of you who know where the markets have gone now in the state of Maine know that low-value timber is even lower in value, and it's hard to get rid of. And so we don't want to be trying to grow pulpwood. I know there's probably a few industry foresters in here who are gritting their teeth right now at me. But and I grew up growing pulpwood. That's what I first started doing in the state of Maine. But right now it looks like that's a loser. And some of these techniques that Peter's going to be talking about, they've been practiced in Europe, in France and Germany for many, many years, where they were not seeking to grow low-value timber. They were trying to grow large, high-value stems.
Of course, the hard part about growing high-value trees is that there are many conditions and critters out there trying to take away that value. Once again, Peter Kleem.
Okay, two more things before we walk. I talked about the problem we have with insects. We're going to see a lot about damage on nice maple trees from the maple borer that destroys beautiful trees. But I also mentioned the white pine weevil. There's an example of it. If you look at this fork, right there, that's where the first damage was from a weevil, and you see what happens is the counts will continue up around, and of course if ultimately you do have a large tree, then that area of damage prevents you from having the inside of a beautiful knot-free log. And that's a big problem here, the white pine weevil. There's one that hasn't actually had one, and I sprayed it when I discovered it. This one was hit as well, and this one was hit also.
So there's a lesson. If you're faced with multiple pests, always choose the lesser of two weevils. And here's another lesson. Success makes for a good radio show, but failure is much more entertaining. We're hiking uphill to where the experimental chestnut grove has been planted. We come up on an area of sugar maple that has been thinned to encourage growth. As it turns out, too much growth. You can overdo this whole thinning thing. You can let in too much sunlight.
Here was a grove that a year and a half ago, 2 years ago, was so dense that you literally could not walk into it. And we saw sugar maple saplings that were separated maybe by 6 inches. Now Gary pointed out that down this way, and you can't see all of it, was an old logging trail. And the machines undoubtedly ground up the ground, and the seeds came down, and it was nice and open, and it just created a prolific growth of saplings of sugar maple. So what do you do if you want to do it? You thin. I was a bit overzealous and started to thin quite extensively. Remember, they were about this far apart. The good thing was because they were competing for light. It's good to have them be close because they wanted light and they wanted to outshine each other. So they're pretty tall, even 2 years ago. What was the problem? The problem was that their diameters were about the diameter of a pencil. And I had thinned quite a bit. It was Gordon who pointed out, he said, Peter, you're going to have a problem. The wind, they're starting to bend over. They did, in fact. And he said, you went too far. It shows you how careful you have to be and how you can overdo a good thing.
If they grow too fast, they're just tall, spindly, and weak.
There's something that everybody needs to keep in mind when they're managing.
This is Maine's chief soil scientist, Dave Roque.
If you had these nice, really tall sugar maples on wet or shallow ground, they'd be flat because they don't have a deep enough rooting system. So if you're going to spend time and money to do something like this, make sure you get good ground. This is really good ground. It's not wet. It's not shallow. It's good and loamy. You're going to have good deep roots, so you can do this. But other ground, it would be flattened. So you need to take into consideration what you have when you start managing for it.
With that, we're going to walk back to the landing, go up the hill, and then we're going to have Professor Brian Roth tell us about the chestnut plantation up there.
That's what we're here for. Though you may already know the story about what happened to the American chestnut, you may learn a thing or two just by sticking around about 3 minutes. That's how long it's going to take us to walk to the top of this ridge. It was once the most abundant tree from Maine to Georgia. It's not now. The story coming up. This is Bob Duchesne's Wild Maine on Sports Radio 92.9, The Ticket. This is Bob Duchesne's Wild Maine. Saturday mornings at 9, Sunday mornings at 8 on Sports Radio 92.9, The Ticket. If you're just joining us, let's get you caught up. Walk with me here as we get up to a grove of newly planted American chestnuts. We're with about 50 foresters and members of the Small Woodland Owners Association of Maine, which is often called SWOME. We're about to look at a project to reintroduce the American chestnut, and we're doing it in a place where they probably never grew, even 100 years ago. That's because this whole 140-acre site is a forest designed to encourage the growth of high-value trees, from selection to protection to sunlight direction. And there's one more reason to do it in a place where they have never grown before. As landowner Peter Kleem will tell us, scientists work very hard to produce a blight-resistant American chestnut. But
no one thought about checking them for frost resistance. I couldn't think of a better place than up here. The winds in the winter, 65-mile-an-hour gusts are typical. That's the northwest exposure, which is the hardest exposure. I think we're around 1,300 feet or so up here. The lake is 1,100 feet. We think it used to be a zone 3, getting a little warmer.
it is warm out today, and it's gotten breezy. You can hear the wind rustling the leaves as Dr. Brian Roth steps in front of the crowd.
So Gordon introduced me this morning as a doctor, and according to my children, not the kind of doctor that helps people. So I do have a PhD in forestry in Florida, and I've been in Oregon and also in northern Canada and Alberta. But Maine is a very special place, and I feel very privileged to work here and to do research in this forest. My day job is at the university supporting an industrial research cooperative with the university. The large landowners in the state, some of which are here today, voluntarily support the research we do with the Cooperative Forestry Research Unit. And it's everything from growth and yield to wildlife habitat, a lot of things that are important to industry and to the people of Maine to manage our forests sustainably. So that's my day job. I'm here today as a volunteer. I'm on the board of directors with the Maine chapter of the American Chestnut Foundation. How many of you have seen a stand of American chestnut trees? You have. Whereabouts? Atkinson?
Uphill in Heartland.
Okay, well that's not pure Americans. That's an experiment. Virginia? In Virginia, okay. So there's some small remnants around, but this is really a thing of the past because of an invasive blight. So before 1904, when we discovered this blight creeping through the native range, the American chestnut was very common in the Appalachian Mountain Range, running all the way from Maine down to southern Georgia. This tree is quite common, 1 in 4. Some people say that a squirrel could run on top of the branches, just jumping from chestnut tree, all the way from the northern Appalachians down to the south. The wood was very special. It's rot resistant. You can make cradles and the sill logs for cabins, fence posts, furniture, coffins. It was really a nice wood to work with. The bark was also used for tanning leather, so a whole tanning industry had sprung up. Same thing with food sources, so it's very prolific cedar, up to 6,000 nuts per tree, and it produces seed, a mast crop, almost every year, unlike some of the local species like the red oak, which may be every other year, and beech, much more infrequent. So this is a good food source for wildlife as well as livestock. And so this was a cash crop for the people that lived in the Appalachian Mountain Range, that in the fall would collect up nuts and fill railroad cars to send to the big cities up and down the East Coast for people to roast on the side of streets and sell them as vendors. So quite a long history with American chestnuts in our region. The chestnut tree is a cousin. It has several cousins around the globe as you go around the northern region. There's a European variety. There's a couple in China and Japan. And so there's this, they're all kind of closely related, and they will interbreed, but they do exist in other places. So we have, in the turn of the century, a lot of people were trying to produce nuts, and we're importing stock from these other sources and making crosses, different hybrids. And these nuts then were not exactly like the American, but in theory had the best traits of both. Unfortunately, along with some of that planting stock came an invasive blight. It came from Asia, China, most likely on Japanese planting stock, sometime in the late 1800s, and it was first discovered in New York. It slowly crept outwards, and by 1940 it had gone through the entire native range and was killing trees from the ground up. So nowadays we talk about the population of American chestnut as being functionally extinct. So it didn't kill the tree outright, it just kills it down to the ground. Because it coppices, it sends up stump sprouts. the genetics are still there, but those sprouts rarely get big enough to produce seed from flowers. And so over time, as those trees die and they repeatedly get infected from the fungus and die back, we're losing this genetic resource. So the American Chestnut Foundation was founded in 1983 with the goal of restoring the tree to the eastern woodlands to benefit the environment, wildlife, and the society. And so it's really a unique thing in that we're restoring a species, and that's rare. It's something positive, it's something exciting, something that I really believe in.
That's Dr. Brian Roth from the University of Maine and the American Chestnut Foundation explaining why the most abundant tree in the East disappeared. We still have 2 stories to tell. What did they try to do about it, and what are we doing about it now? The now part is the whole reason we're standing on this ridge on the west side of Moosehead Lake in front of a whole bunch of tiny seedlings. Stand by. Bob Duchesne's Wild Maine continues in a moment on Sports Radio 92.9, The Ticket. This is Bob Duchesne's Wild Maine on Sports Radio 92.9, The Ticket. At one time, 1 out of every 4 trees in the Appalachian Forest from here to Georgia was an American chestnut. Then tragedy struck. A blight came in from the Far East to which our native trees were not immune. It spread like a falsehood on Facebook. Before long, every chestnut was dead, save for a few in isolated pockets. Dr. Brian Roth is a forestry professor and board member of the American Chestnut Foundation. Scientists have been trying to bring chestnuts back, an effort that has been going on since trees first started dying off.
The breeding effort that they use is called the backcross breeding method. And I put a little diagram in this handout, but it involves taking the resistance genes from a Chinese chestnut, and you can imagine that the Chinese tree co-evolved with the fungus in Asia. So if you're a parasite, you don't want to kill your host because you're sort of putting yourself out of home. So they kind of co-evolved where it didn't kill the tree, but they got what they could out of it. However, the American chestnut, not having seen that fungus, had no resistance. We think that it really has no resistance, and the few remaining trees we see around, it's just the fact that they're isolated and the fungus hasn't got to them yet. We're not going to get rid of this fungus. It's here to stay, and so we need to take some drastic measures to see if we can't bring this crop back. One of them, as Peter mentioned, is working with hybrids between Chinese and American. The difference between the Chinese tree, the Chinese has been bred for thousands of years to be an orchard tree. So they're looking for trees that grow low to the ground, are easy to collect the seeds. Maybe they grow big seeds, but they don't grow tall and straight like the American trees that we have here. That would be a problem if those trees, we tried to introduce them in Maine, because our native hardwoods are so much more aggressive and will shade them out. So we're trying to find something that's got the best of both traits, the disease resistance from the Chinese tree and the American traits that make this tree so special to us here in North America, and combine them. And that's where we come up with this backcross breeding method that's the backbone of the American Chestnut Foundation. So the foundation is a nonprofit. It's entirely run with volunteers and donations from people just like you all over the country that care about what we're doing. There are 16 chapters running from Maine all the way down to Alabama, plus a national organization that works on some of the higher level science and breeding and education and the like. So the backcross breeding method, a little diagram, you can see successive generations. We're talking 6 generations of breeding just to get something that we hope is going to be resistant. The idea is to capture all of the genetic variation in local populations here in Maine. And there are a few native trees around. We talked about the ones up in Atkinson, and there's several scattered around in the native range. Trying to incorporate that material in through a backcross breeding program. So at each generation, you start with a pure Chinese and a pure American. That was done back in the 1940s. And then the seed from it, planted out, and then cross it back with another pure American. So at each succession, you're going from half American to a 3/4 American, 7/8 American, finally ending up with 15/16. And that's what Peter was saying about the 94 to 97%.
If I can add to that for a moment.
Peter Kleem can add anything he wants. We're on his land. Land that he's open to the public, even by creating a trail system for everybody. Land he is open to wildlife by creating a sanctuary. Land he is open to trees by experimenting with how to grow high commercial value trees on a relatively small woodlot. This woodlot. Because trees grow more slowly than lab mice, it takes a while to see what you've got. Researchers would wait until a chestnut tree grew to a certain size, and then they would deliberately subject it to the blight fungus. Any tree that showed significant resistance was saved. All others, eliminated.
As they spread these small seedlings, let's say the 50-50 or 75-25 and so on, when they were about this high, people went around and still did it until last year, and they would cut and damage the bark at about 18 inches high and then a little higher. And then they would smear just a tiny amount with a Q-tip or so of the fungus into those areas. And as I understand it, they had a severe fungus blight thing that would go on the bottom, and one that was more moderate and not quite as bad, a little higher. As I was told that the order of that was, so when it rained, the severe one wouldn't wash down. But in a very short period of time, you actually had a metric, namely, where this particular sapling over here partially resistant or not resistant at all, or apparently quite nicely resistant. Then something like 1 or 2% were saved, all the others were cut back, and then those were propagated again to further and further improve the blight resistance.
Still, it's a pretty slow process. Dr. Brian Roth.
All those genes are getting mixed up and jumbled up. But how do you know if a particular tree has inherited the genetics that you're interested in? It's an absolute roll the dice crapshoot. You need to look at thousands of individuals and actually test them. And what Peter was describing is how we inoculate the trees with lab-grown cultures of the fungus. Just like people, there's variation within that population of fungus, and some are more virulent. That means they're stronger than others. So we take both the weak and the strong and apply them to the same tree, and then come back and look at each one and see how did it do. Is this one more resistant than the others? The ones that aren't, they die. We physically cut them down and just keep the top few percent. And those go on to the next generation of breeding. So that's key. Without that screening step, we'd just be looking for a needle in a haystack. So we're kind of guiding the natural selection process in a way, trying to speed up evolution with the goal, when we're done, that these trees that we put back in the wild are still going to have some susceptibility, but nature's going to do the rest. It will sort out the ones that are not resistant. They will die. The ones that are healthy are going to produce seed and pass their genes on. So I think we're getting quite close to being at a place where we could release them in the wild and nature might be able to take it from there. That's the idea.
So there you are. You've done your backcross breeding. You're up to a strain that is 15/16 the same as the original American chestnut. How close to the original tree is close enough? How soon can we start planting chestnuts all over the pine tree state?
We get to a tree that's 15/16. We've done a couple generations of intercrosses. We think in Maine, with our breeding program here in our chapter, we should be there by about 2020. So much sooner than you think. Probably 3 or 4 years, we'll just have the very beginning of some seed that's potentially resistant and adapted to Maine. Still going to need more testing and more selection, but we're just getting to that stage. And what we're talking about are seed orchards. You get to a point where now you have the trees that are resistant. Now you've got to propagate them and get a lot of seed off of them. So of the very few trees that make it, we're going to be producing seed, and those will go into reintroduction trials, very similar to the one that Peter has here. This one is probably the most northerly, well, I know it is. It's the most northerly planting of potentially resistant, what we call B3, F3. These are backcross trees, are sixth generation in the world. They don't exist in Canada because they have to stay within the States. There is some work going on in Canada, but for the material we're working on here with the Chestnut Foundation, this represents the most northerly part. There's some in Vermont, just south of here, and we have some in other parts of the state. So Peter begged me to put in a trial here, and that's why we have something so far north. It's well outside the range of where we would expect chestnut to grow naturally. However, after touring Peter's place and him showing me all of the trees he has got growing here over the past few years, but more importantly, the dedication he has to detail, his science background, and just the desire to see something happen and to make a difference is why there's a trial here today. And I think it was almost exactly a year ago that we were standing here just talking about this idea. And now it's a world-class trial. There's replicates to this trial in other parts of Maine. There's some in Eastbrook. There's some down in Biddeford. There's also some in Dixmont in the community forest there.
So all this is going on around you. You know the forest as it is today. Lots of maple, oak, birch, beech, pine, hemlock. Up through southern Maine, lots of balsam, fir, spruce, cedar, tamarack as you head north. And somewhere in all of this 100 years ago, American chestnuts beat them all. The blight that killed these trees is still here. So if we're going to restore even a few chestnuts in the wild, we've got to figure out how to beat it, which is next. This is Bob Duchesne's Wild Maine on Sports Radio 92.9, The Ticket. This is Bob Duchesne's Wild Maine on Sports Radio 92.9, The Ticket. Today's show is coming to you from Greenville, where an attempt is underway to restore the American chestnut, a tree that was so numerous that it outnumbered every other species. 100 years ago, a blight from the Far East was accidentally released into America, and now the chestnut is almost extinct. But we're not giving up without a fight. After decades of trying to produce a blight-resistant American chestnut, we're starting to grow them in the wild. And that's happening right now, right in front of me, in a test plot on the land of Peter Kleem here on the western shore of Moosehead Lake. Professor Brian Roth of the University of Maine, take it away.
Okay, so we'll talk a little bit about this experiment that Peter has on his property. There's kind of four main things that we're testing. We're testing the effect of the overstory. Peter mentioned we have some areas that are open and some that are closed in a partial shelter wood. And that was by design. That's something that Peter and I talked about before he sent his loggers through here. Then we have a type of vegetation control. This is the site preparation that we would do before we plant the trees. So half of those areas then had a herbicide spray to control the sprouting beech trees only. And then on top of that, we came back then in last spring and planted 3 different sizes of chestnut trees. We planted just pure seeds directly into the ground. That's just direct sowing in the spring. We planted seedlings that we had grown in the greenhouse in little containers. These were grown by the University of Maine students. There was a small group of them that were taking a wildlife conservation course, and the professor there, Dr. Amber Roth, wanted them to have some service learning projects, and some of them chose to work with the American Chestnut Foundation. So they grew those seedlings and they came out here and planted them also. And then we also have bare root stock that was grown at the Pennsylvania State Nursery. And that bare root stock then is a year old, but it's much bigger because it's grown outdoors for a year, then put in cold storage over the winter, and then we planted it out. The last treatment we have here, and Peter was fond of this because he has a deer population that he's supporting, is these tubes, the tree shelters. So in talking with Peter, I said, we have to have some that we don't put tubes on at all. And he said, no, I don't want to do that. I said, we need to do that. So you'll have 1/3 of the tubes here that don't have, there are no tubes. There's a tree with no tube. And every combination that we've talked about previously, then some that are a medium height and some that are a taller height. And so we're going to, because they're expensive, they're difficult to put on, and we'd also like to see maybe there's some trade-offs. Maybe the trees inside the tube don't do as well as the ones that are growing on the outside that have come out of the tube. So those are all of the main factors that we're testing here. And as we walk down this road, as we go, the experiment is all laid out along the edge of this hillside, you'll see rows. You'll see rows of tubes. You might see a number on them as we go. And they represent all these combinations. There's something like 16 combinations of treatments that we've done. They're replicated 4 or 5 times. There's multiple replications within the rows. 300, I think, entries in total are out here that we track.
So that's what I see in front of me. A spot has been opened up in the woods here on the top of this ridge. Part of the plot is open to the sun, part has some light canopy shade, some of the competing beech trees have been eliminated, some just controlled. The three types of plantings are seeds, seedlings, and bare rootstock. These are lined up next to each other so that they have the same growing conditions, and the threesomes are spread out through the plot. Then, some are protected by tall tubes, some short tubes, and some no tubes. So the experiment is controlling for sunlight, competition, deer protection, and planting method, trying to determine what has the best chance of long-term success, here in a location farther north than its traditional range, so that we can also test frost resistance. That's a lot of different variables, all combined in a plot that you could walk around in just 2 minutes. How did this work in the wild, when chestnuts were everywhere and didn't need our help?
We harvest them in the fall. What'll happen is they'll drop down, the blue jays will grab them, they'll stick them under the rocks and in the soil, hide them for the winter. And over the winter, there's some dormancy chemicals inside the seed that need cold temperatures to break down. And so that's the mechanism that allows them to sprout in the spring rather than the fall. If they sprouted in the fall, they'd have a tough time. White oak, that's a different story. White oak does sprout in the fall. It doesn't need any stratification. But for chestnut, it needs a couple months of sub-freezing temperature before it'll germinate. So we'll take our seed that we collect and we'll put it in a Ziploc bag, put a few holes in it just so that it doesn't get moldy inside there. There's a little bit of oxygen exchange. Put a handful of peat moss, just damp, not wet, but just to the point where you can squeeze it and no water comes out. And that will sit in your crisper in your fridge, or if you have a freezer that goes just a little bit below freezing, you can put it there, and by March those things will be ready to grow. As a matter of fact, they'll actually start sprouting inside the bag in your fridge. Yeah, and then you can plant them out. So we were talking about the effect of survival when it's bare root, and Peter and I were having a debate on our walk up the hill. What is it with these ones that are not doing well where there isn't a tube? Saying, well, they didn't germinate. But I think that if we dug around in these empty holes, we would not find the carcass. We should be able to find the little hollow nut in there with the rotten meat inside it if it didn't germinate. I think something came here and ate them. Yeah. We're going to look for a couple of these that are dead. I have a list of them. And we'll dig down and see if we can find the nut. But I bet that it's missing, that some squirrel ate it. I think they probably, the day we finished planting, something was wandering around out here and got them. So that's one more advantage for having a shelter that you can push down into the soil a little bit. It keeps them from being girdled also, but also it protects that nut from getting dug up.
Let's pause it right there for a moment. After my day in the field, I got an email from Dr. Roth. He did indeed go digging for the seeds that didn't sprout. He reported that he found an equal number of holes with and without seeds, and his theory that all of them had been eaten went down the tubes. He says maybe it's a soil temperature thing, with conditions in a tube being warmer, and thus better for germination. Whatever the reason, it looks like planting seeds isn't the way to go. You have potential squirrel problems, germination problems, and if you go without a tube, deer problems.
So whether you grow them in the winter in the greenhouse and then plant them out as seedlings, or if you direct sow them, it looks like they end up about the same height over time. But if you look, the survival is a problem if you don't protect those bare seeds. So I don't think the preliminary, after year one, I shouldn't, jump to conclusions, but I think probably you don't want to plant bare seed. You should try to grow a seedling and get that into the ground, would be the way we're going to be reintroducing this species in Maine. But I don't know. Ask me in 10 years. We'll have more data. So every once in a while I get an email from Peter. Usually there's a picture attached, and it's some twig that's just been browsed to high heaven. There's nothing left. And he said, the deer are eating your experiment. And I said, great, that's good. We need to learn something. That's why we do these experiments in the real world. We have enough treatments out here that there's going to be something we're going to learn from it. Maybe we learn that the deer ate the whole thing, but at least we'll learn something. And you can see that this is a weighted browse severity. So Peter and Andy went from tree to tree and looked at every seedling and gave it a rating from 0, being no browse at all, to a 5, which is this thing is severely, heavily browsed. And there is a standard to all of those things. And I averaged those numbers to come up with this weighting. So it's not just the occurrence of browse, it's how heavy did they hit it. Just nipping the top off is one thing, but stripping it all the way back, taking all the leaves and making it shorter than it was when we planted is a different story. Looking at this one here as an example, anything in the tall tubes was not browsed at all. And where there was no tube at all, like these ones, the severity was much higher. It was 2/3 more than just in the medium tubes.
This experiment is just beginning, but it looks like good news for tube manufacturers. The moral of the story is, no matter how big you are, no matter how numerous you are, there's something out there that wants to eat you. Well, that puts the wild into Bob Duchesne's Wild Maine. Today's show about the American chestnut comes from Greenville and a forest preserve open to the public in the land of Peter Kleem here on Harford's Point. This has been a demonstration workshop put on by the Small Woodland Owners Association of Maine, and my thanks to them for letting me crash the party. Bob Duchesne's Wild Maine is brought to you by Hammond Lumber, Doors Equipment, Bar Harbor Whale Watch, Napa Auto Parts, and EBS. Bob Duchesne's Wild Maine returns next Saturday morning at 9 and Sunday morning at 8. And remember, all shows are archived at 929theticket.com so you can re-listen or share the show with anyone. This is Sports Radio 92.9 The Ticket.